I had some slides. I don't have them today, so I will just do the demonstration, and I will try to remember what was on the slides. Okay, you should see my, what is it doing now? Wait, this was something with the dock or something. Let me see. Can you stop this, please? Thank you. Okay, so let me get the, where's the demo? I don't have the demo here. I need the USB stick. One sec. Wrong computer. I'll be real quick. There we go. Oh, and I have to revoke a statement I did earlier. I got asked about ozone and if you can call it in command line. The answer is actually yes, you can. I understood the question a bit differently. You can call it via command line, and you can script ozone. So every GUI stuff you can do there, you can script and then call via command line, and then it will do it magically. I will also show a demonstration of this. Let me just get the samples right here. So yeah, I will show the automation and the tutorial project. So let's start maybe talking about the platform again. So we have this JTrace here. When you get the JTrace, you also get this little board, so you can get started in something like 10 minutes, which includes installing ozone and downloading the sample. So there's not much setup consideration here. So again, here you go. So I got the Cortex-M tutorial. That's what you usually end up with first when you want to test out your new shiny toy. And this is also a good demonstrator on what features you get here. The idea with this prop usually, or a bit of hardware background here, what we use here is the ARM streaming trace capabilities that are built in most Cortex-M, in most ARM Cortex devices. This is a Cortex-M platform based on STM32F4. And the prerequisite for this to work at all is you need to have a target device that has this on chip. Otherwise, we can't extract the data. It is non-intrusive, so it is some core side module from ARM that hooks into your CPU without touching anything, any of your code base or slowing down your CPU or anything. So it's completely non-intrusive, and it essentially listens to your CPU core and and sends out the data what your CPU is doing at all times, and you will get all instructions that have been executed without any gaps and stuff like that, which you sometimes get with other trace features. So yeah, that is the technical background. To extract this, we use the trace pins. That is another prerequisite. So additionally to the debug pins that you have, which is, for example, JTAG, you also have to implement the trace pins, which are 5 additional pins, so 1 clock, 4 data pins. Yeah, so let's get it up and running. So I loaded the project. I just start the debug session, and we landed up at main, as we're used to. And let's take a look first here in the top left. I hope you can see it. Yes, you can. Okay, it's the instruction trace window. So if we go back in time, we see that we really start at the reset handler. If I click in here, you see that all these windows are interconnected. So we can really step back in time and see, okay, what has happened with C source or C++ reference here in the instruction trace window, and know exactly where we have been in the past at all times. You see code profiling here, so you know how often which line has been executed, has it been fully executed. Yeah, let me just let it run for a while, and you will see that the counters, where is it? Here you go. They also update live, so this is not buffered or anything. This is streamed over the USB 3 cable here, shiny blue one, and we analyze this in real time. If I hold it, it will hold exactly at the number where we, okay, we jumped now to another section of the code, but here we were before. So this is the counters that you can use here and analyze your software. As you now see, we are mostly, oopala, where did I jump to? There we go. We see we have a couple of branches because this is a simple blinky LED application with 2 tasks running on the RTOS, and yeah, most of the time we don't blink, so we're idle. So that's why we spent a lot of time here. Now to pick up this code coverage talk we heard earlier from Marius. So this is also something that you can do with this tool. We take this information that we gather live with all these updates, and we know what has executed when, how long. We get timestamps, so we're cycle accurate here. And you can also find here the code profile and code coverage window, which gives you information about your source coverage. So if I sort by source coverage, you see, okay, reset handler has been fully executed. System init has been fully executed. There will be some program parts, for example here, some system view functions have not been fully executed yet, and things like this, which then can be used for system analysis. Then, as I said in my talk, we also have a timeline which shows this. Let me see if I can zoom with the touchpad. Yeah, kinda. Okay, I zoomed out a bit far, but come on, I can do it. Let's do it here this way. More. So the spikes you see here, I'm nearly there, are our sysdig handler. Come on, there we go. Which we see now in a, say, call stack fashion, where we see, okay, what application parts have been executed when. We see exactly how long this has taken in microseconds here. And yeah, this can help you analyze your whole setup much better. And yeah, as I said, it helped Stefan recently with an issue, and it's great to know at all times what your system was doing, and this can give a nice insight. Now I'll quickly show the automation demo I talked about, where we have a scripting interface for Ozone. I hope I have a proper text editor here, otherwise it will look a bit weird. What do we have here? Open with Notepad. Notepad is great. Okay. Yeah, it's a C-like API. You see on project load, and this whole part is auto-filled when you create Ozone project. So this is nothing you have to worry about. This is where you set your device, how fast it is, what interface you're using, blah blah. And what you need to type in code is this part essentially, and that is it for a simple trace automation where we will run to 3 different breakpoints. We will set callbacks for each breakpoint hit where we will do something. The something is here. The first hit will just sleep and continue, the second as well, sleep and continue, and the last one will do a trace export of the trace data that had been gathered until that point, and the rest is other hook functions that you can use for automation again. So yeah, let's run this. I need just to create a folder in, where is it? C. Yeah, and I make a new folder because it will save the reports in C Zegger, just so the test doesn't fail and I look stupid. All right, then I will just drag and drop this now and put it on Ozone, but you can also use the command line to call this, and you will see the test will open. It will connect to the target. Here we see in the console what's happening. Whoa, where we go? Okay, breakpoint 0 hit, breakpoint 1 hit. Then we got the wrong timestamp. That happens sometimes depending on how not nice the target is to us. And we got the exports. Now we can check out the folder again, and we see we got CSV and text exports of exactly the trace windows you saw earlier. So here's the instruction trace. It's not formatted, of course. Usually it's formatted if you open it in a proper CSV editing tool and not Excel. Yeah. But it is formatted like you saw in Ozone, so this is usually how it would display in a proper tool. Then you can get a humanly readable version. You can also filter, so if you say, okay, I have some test cases I only want to cover and the rest doesn't interest me, I don't care about my system in it, I don't care about my reset handling, and I don't know, you can filter this all out and then just have this humanly readable report, which you can, I don't know, give you a quality assurance team and say, hey, my tests all have been covered and my other analysis tools have shown that our code is doing what it's supposed to, so we have a great product here. And here are two other versions of this export of the code coverage, one showing per function level and one showing per line level and source and in which source we are. This again a bit not formatted in this tool here, but here on the left you see the function names, and then you see how often which line has been executed, etc., what you saw graphically in the code coverage window. And here it is for the source lines. So if you have C or C++ sources, they will be listed here. It will tell you the line number, what is the C or C++ code reference to it, and here will all code show up that creates instructions. And yeah, that's how you can get your information for further analysis of your system. So yeah, this would be the overview of the features that you get if you really go and say, okay, I want to trace on hardware without impacting my running system. And I think it can be helpful in many cases. Thank you.